In this video, we will build 4 small projects completely from scratch. We will learn how to generate groups of animated computer-controlled characters for our games, and we will explore 4 different movement animation patterns. I went to the forest and I caught some dangerous magical creatures for you. Today we will study them and learn how they move. Some of them have wings, some of them spin around, and some just float in the air. It will be interesting to explore their movement patterns. This is Creative Coding Tutorial for Beginners. Let's learn fundamental vanilla JavaScript principles and techniques by building fun projects together. Hope you get a lot of value today. Art for this episode was made by this amazing artist. Go check out his website if you want to see more. We will cover 4 different movement animation techniques, and by the end of this video you will have 4 complete projects, and you will be able to introduce a variety of different enemies and movement patterns to your personal JavaScript games. Sometimes we tend to make our games too easy and predictable. Let's give our players some challenge by including different enemy types. I know that many people who watch this channel are on their way towards success in life. It's more about hard work than it is about talent. And when you realize that and when you believe that, it's much easier to put all the necessary work in. This work compounds over time, and it will put you ahead of other people who are watching TV while you are coding. There's this famous motivational quote: "Today I will do what others want, so tomorrow I can do what others can't." Many of you ask me what are my secrets to success. Today I will give you one. If there is one book every self-taught programmer should read, it's Atomic Habits by James Clear. It's so packed with easy, actionable productivity tips and tricks. You can just apply them immediately as you read it. Mostly it's about how to motivate yourself to show up consistently and create long-term positive habits. It's about how to create patterns that lead to success and how to kind of trick your brain so you enjoy the process. Science of making habits. I could talk about this book for an hour, but let's move on. Sometimes I like to listen to audiobooks when I go for a walk, during my workout, or when I'm traveling. You can get this book completely for free if you sign up for 30 days Audible trial with my link in the video description. I love listening to audiobooks. It's like somebody's giving you their life experience distilled into a couple of hours. You get all that knowledge basically for free. There is so much value in non-fiction books. Give it a try if you want, it might change your life. I create a simple web page markup, I give it some title, I link style CSS file in document head. We will draw everything on canvas, so I create it here and I give it ID canvas1 so that we can target it with CSS and JavaScript later. I also link my script.js file, which will contain all animation logic. In style CSS, I take my canvas element I just created and I want to give it some border, size, and I want to center it in the middle of the page. So border 3 pixels solid black, position absolute, top 50%, left 50%, transform translate -50%, -50%. Now it's in the middle. Let's make it vertical, so height 1000 pixels. Width will be, for example, 500 pixels. Everything else will be drawn with code in the script.js file. This is a beginner tutorial, so don't worry, I will take you through it step by step. As with every canvas project, I need to point JavaScript towards my canvas element we just created in index.html. I do it by using getElementById, and I pass it ID I gave my canvas element, canvas1, like this. CTX, shortcut for context, is equal to canvas.getContext, and I pass it 2D. We will use a built-in set of 2D drawing methods today. Now I can call all these built-in methods from my CTX variable. If I type CTX dot like this, you can see that in VS Code Editor, my autocomplete feature doesn't suggest any built-in canvas methods. If I want them to be suggested, I can go up to line 1 and type @type HTML canvas element like this. This way I tell VS Code this is a canvas project and it will suggest built-in HTML canvas methods for me. You can see arc method here to draw a circle, clear rectangle to delete paint from canvas, and so on. We will use some of these in a minute when we start drawing and animating, but first let's quickly finish canvas setup. We need to set canvas width and height to make sure we get correct scaling of our drawings, so I create a custom global variable called canvas_width. I set it equal to canvas from line 2 dot width, and I set it all equal to 500. Canvas underscore height is canvas dot height is equal to 1000. These values need to be the same I gave it in style CSS. I want to create a factory function that will produce many similar objects for me. Each of these objects will be one animated enemy. Before we create many enemies, let's just build one and make it absolutely clear for beginners what's going on. When we have that, it's easy to scale it up. I will create a temporary enemy1 variable and I set it equal to JavaScript object. I give it x and y properties and I set them to 0. These will represent horizontal and vertical coordinate on canvas where we draw that enemy. I will also give it width of 200 pixels and height of 200 pixels, like this. So now I have this simple JavaScript object that is storing position and size of one enemy. Let's animate it. To create animation loop, I like to write a custom function I call, for example, animate. Inside, I call built-in fill rectangle method. This method expects x, y, width and height of the rectangle we want to draw, so I will give it x, y, width and height of this enemy object. When I call animate like this, we are drawing a black rectangle representing the enemy object. I can change its values, and when I refresh the page, it will be reflected on canvas. We are not animating yet. What if I want the horizontal x position to be slowly increasing to make the enemy travel to the right? I can say for each run of animation loop, increase enemy1.x property from line 8 by 1. To create animation loop, I call built-in request animation frame method. I pass it animate. Now animate will run all its code and then it will call itself again. This will create an endless animation loop. I also need to delete old paint, previous frames from canvas. I do it by using built-in clear rectangle method and I clear canvas from coordinates 0, 0 to canvas width, canvas height. Now we see only the current animation frame. I can also increase vertical Y position by 1 for every frame, so we get movement towards bottom right, like this. I can change width and height of my enemy easily. You get the idea, I think. Let's comment out this temporary enemy object and make it into a JavaScript class, so that we can generate a large number of enemies at once. JavaScript class is kind of a template to create many similar objects. It's a factory, and every time we ask it, it will produce one new object for us, based on a blueprint we give it. Classes are a new syntax for older JavaScript prototypes. Under the hood, it's the same thing. It's just so-called syntactical sugar. Simpler, nicer way to do the same thing. Classes are very easy and intuitive. Let me show you. We use class keyword and then we name our class starting with a capital letter. My class will be called enemy. Constructor is a mandatory method every class must have. It will contain a blueprint based on which every enemy object will be created. So here in constructor, I just give it x, y, width and height, same as we had in this simple enemy object on line 7. The syntax might be a bit strange at first. Here I'm telling my constructor, on this new enemy object you are creating right now, give it property called x and set it equal to 10 pixels. Starting vertical y coordinate will be 50 pixels. Width will be 100 pixels and height 100 as well. So this is how you recreate single JavaScript object into a reusable class. Now we can call our enemy class as many times as we want and each time it will generate one new enemy for us, based on a blueprint inside constructor method between lines 16 to 19. I can delete the old code. And now these variables are undefined because enemy1 doesn't exist. So I create a new constant variable called enemy1 again. And I set it equal to an instance of my new enemy class. To do that, I use the new keyword followed by a class name. The new keyword will simply look at that class name in my code. It will enter its constructor. It will create one new blank JavaScript object and it will assign it values and properties based on a blueprint inside the constructor. Now, my fill rectangle method on line 21 can use these values again to display a rectangle. What if I want another enemy? I can create another variable called enemy2 and I set it to new enemy again. Inside animation loop, I take enemy2 and I increase its x and y coordinates as well. And on line 25, I need to draw another rectangle representing that enemy like this. They are moving at the same speed in the same direction, so we can't see the second one. Let's adjust its speed, for example. Now we can see that there are two of them. We can control them separately like this, but this wouldn't be very efficient if we had, let's say, 50 or even 500 enemies. So how do we make this code better and remove repetition? First, let's output this code between lines 21 and 24 that handles movement along X and Y axis into a shared class method. That way, we can write this code only once and it will be available to all objects created by enemy class. I will call that custom function, for example, update, and as I said, its job will be to update coordinates of my objects. It will handle position calculation and movement. So inside I say for every frame, increase X by 1 and also increase Y by 1. Let's delete all this code, and to run update method I just created, all I have to do is call enemy1.update like this. Since enemy1 object was created here on line 19 as an instance of my enemy class from line 7, it automatically has access to this new update class method from line 14. I also need to remove line 25. So now we put all movement calculation functionality into this update method. I also want to put this drawing code into its separate method so that we can draw all enemies at the same time. We can also give them animated sprites and so on. I will show you in a minute. On line 18, I create a custom draw method. Inside, I call ctx fill rectangle, the same way we did here on line 27, but instead of hard-coding enemy1 object here like this, I will use this keyword. That way, this method will be reusable and can animate not only enemy1, but also enemy2, enemy10, enemy100. It can animate all the enemies created by this class at once. On line 27, I can replace these hard-coded values with enemy1.draw. It will look the same, but now it's reusable and scalable. Inside constructor, between lines 9 and 12, all enemies start at the same X and Y coordinates. So if I create 50 enemies, they would all stack on top of each other and wouldn't be visible. Let's randomize that. Every time I create a new enemy, its horizontal X coordinate will be a random number between 0 and canvas width. And vertical Y coordinate will be a random number between 0 and canvas height. Now, every time I refresh page, my enemy appears at a different position. I could also randomize width and height if I wanted to make each enemy random size. I think you get the idea. So how do I create many enemies instead of just one? I comment out line 22 and I create a for loop. This for loop will run, for example, 100 times. Actually, let's go up to line 6 and create a constant variable called the number of enemies, and I set it to 100. And I replace hard-coded 100 on line 24 with this new variable. That's better. We shouldn't be hard-coding values if we can avoid it. I want this for loop to run 100 times and create 100 enemies for me using my custom enemy class. But how do I store all these enemy objects and their properties, such as their X and Y values? I can, for example, go up here to line 7 and create a custom variable called enemies array, and I set it equal to an empty array. Down here on line 26, I take that enemies array and I call built-in array push method. Push method will just take whatever we pass to it and it will push it to the end of the array. I pass it new enemy. Every time this for loop runs, and it will run 100 times, it will create one new enemy using my enemy class constructor, and it will push that new enemy into enemies array. It's the same as we did with enemy1 on line 24, but here we are doing it 100 times. Let's delete line 24. I also have to comment out lines 31 and 32 because enemy1 variable doesn't exist anymore. How do I access all these 100 objects I just pushed into my enemies array? And how do I trigger their update and draw methods one by one so that they can be animated on canvas? First, let's console log enemies array to make sure that for loop on line 25 did its job and filled it with 100 objects. In console I can see we have 100 enemies and each one has randomized X and Y coordinate. Perfect. So as I said, the goal now is to cycle through all 100 enemy objects inside enemies array and to trigger their update and draw methods. This will need to happen for every animation frame over and over. because we need update method to constantly recalculate enemy position and the draw method to draw them at that new position. On line 33 inside animation loop, I take enemies array that contains my 100 objects and I call built-in array for each method. For each simply calls provided callback function for each element in the array. I will use new ES6 syntax with arrow function here. Inside my for each callback, refer to each individual object as enemy as you cycle through enemies array. And for each of these objects, call their associated draw method and also their update method, like this. Perfect. You can see that each rectangle appears at randomized X position and they all move in the same direction because of lines 17 and 18. What if my enemy had randomized speed? I create a new property called this.speed and I set it equal to a random number between -2 and +2 because I want some of them to go to the left and some of them to go to the right. If you find it hard to read this line of code as a random number between -2 and +2, think of it this way. This part of code generates a random number in this range, so between 0 and 4, and this number sets the start of that range. So we are generating a random number between 0 and 4, but we are pushing that range to start from -2. So result we get is a random number between -2 and +2. I remember I always found math.random very unintuitive until I found a better way to think of it. Anyway, now I have this.speed property and I can replace it here on line 18 for horizontal position and also on line 19 for vertical position. Now you can see we have rectangles moving in many different directions. I delete code on line 29 and also on lines 32 and 33. On line 21 inside the draw method are enemies that don't have to be represented by a black rectangle. We can write any drawing code here and it will be called and replicated for all enemies at once. I can, for example, try stroke rectangle instead. We can also draw circles, stars. You can put selfies from your holidays to represent each enemy object here. We have complete flexibility. What I want to do here is to create animated creatures because we want these to be enemies for our JavaScript games. With this video, we are giving away 4 different animated enemies, drawn by this amazing artist. Go check out his website for more content. He is very talented. He allowed me to share these sprites with you for educational purposes for free. You can download them in the video description, and you can also find a link to his website there. If you want to use these sprites for commercial purposes, you would have to go to his website and buy a full license. They are free only for purposes of this educational video. Show him some support if you can. We don't have many good 2D artists like this. If we support them, they will be able to create more beautiful game art assets for us. Today we will create 4 different projects. Each one will have different enemy with a different movement pattern, and on each one we will demonstrate different beginner-friendly movement animation technique. I want you to always have a nice complete project at the end of my videos, so that you have something to show to your friends or on your coding portfolio. It feels good to complete something, don't you think? You can use these as animated backgrounds or a screensaver, or you can take this code and slot it into your personal games. It will be compatible with my previous games if you followed these tutorials. Let's start with a very simple one. The first project will have bats flying in random jumpy patterns, perfect for Halloween game or even a website, for example. I'll leave the creative applications of this on you. First, I need to bring new image into my JavaScript project. To do it, I create a custom variable called animeImage and I set it equal to new image. animeImage.src is equal to anime1.png if you are using the same sprite sheet I'm using. It might be a good idea to use the same files at first and follow along, and once you understand the code, it's easy to adjust it and to use your own custom images. On line 26, inside the draw method, I call built-in drawImageCanvas method. We will use it to animate our bat sprite sheet. I will explain sprite animation quickly as I code, but if you need more detailed explanation, I made a special video where I focus on it in depth. I will link it in the video description. ctx.drawImage, and I pass it image I want to draw, and I pass it x and y coordinates. And this is what we get. We can also pass it optional width and height arguments, which will scale the entire image into that specified size. You can see it pushes the entire sprite sheet with all 6 frames inside the rectangle. We don't really want that. We only want to crop out 1 frame at a time, And we want to be jumping by the amount of sprite width to the right to display the next sprite frame. We want to go frame by frame from left to right until we reach the last frame. Then we want to jump back to the first one and start again. We can do this with the draw image method because it offers additional 4 optional arguments we can pass to it. Let's go up inside animate constructor to create a property called sprite width. I check my sprite sheet, divide its width by the number of frames, and I can see that width of a single frame is 293 pixels. Sprite height of this particular sprite sheet is 155 pixels. Now let's add additional 4 arguments to draw image method to tell it what area we want to crop out from this sprite sheet to display only one frame. Let's start by displaying just frame 1. So I want to crop out area from coordinates 0, 0 to coordinates sprite width, sprite height. Now we are drawing just frame 1. So in this version of draw image method, we are passing it 9 arguments in total. The first is the image we want to draw. The next 4 represent the area we want to crop out from the source sprite sheet. And these last 4 arguments determine where on canvas we want to place that cropped out frame onto. You can see my bars are slightly distorted because I'm stretching them to fit this dot width and this dot height here, which are unrelated to the actual dimensions of my bat enemy character. Ideally, I want to preserve the aspect ratio, so I make width and height relative to the sprite size. I take width and height and I move them to go after sprite width and sprite height so that they can see these values. Now I can make width 1/3 of sprite width and height 1/3 of sprite height. Now, our bats are the correct ratio. Maybe I want to make them a bit larger. Let's try 2.5. That's better. Right now, we are displaying only frame 1 because of these hard-coded 0, 0 coordinates. Let's cycle through all frames and animate our characters. On enemy class, I need a new property called this.frame and I set it to 0. On line 30, instead of hard-coding horizontal coordinate 0, which will give us this frame, I will take this.frame variable and I multiply it times this.sprite width. That way, when frame is 0, we display this frame. When it's 1, we display this frame, 2, 3, and so on. So now all I have to do is that frame cycles between this and this frame, between 0 and 5. I will use ES6 ternary operator, which is a simple one-line if-else statement basically. I say if this.frame is more than 4, question mark, set this.frame back to 0. Else, colon, increase frame by 1, this.frame plus plus. This should be colon. Our bats are flapping their wings and animating, but they flap very fast and all of them flap at the same time. Let's fix that. There's a proper way to time animation frames using request animation frame and delta time, and I will show you how to do that in some other video. Today let's slow down our animation the simplest way possible. On line 11 I create a variable called game frame and I set it equal to 0. Inside animation loop on line 46 I increase game frame by 1 for every loop. And up on line 28 inside update method I say if this ever increasing game frame variable is divisible by, let's say, 2 with a remainder of 0, only then serve a new animation frame. This line simply means run this code only every 2 loops of main animation loop. If you are getting a little unsure, I made a special sprite animation video where I go in depth and slowly over all of this. For now, let's just move on and focus on movement patterns. Now, bats animate slower, but they all still move their wings at the same time in the same rhythm. I want to randomize their animation frequency. I create a custom property called, for example, flap speed, and I set it equal to a random number between 1 and 4. I replace hard-coded 2 on line 29 with this randomized flap speed value. This will make some of them animate very quickly, some of them slower. Some will animate every 1 or 2 or 3 or 4 frames. It will be randomized. The reason it doesn't work is because math.random returns numbers with decimal points, so game frame is never divisible by that very specific number with a remainder of 0, and frames never increase. To fix that, I just need to wrap it in math.floor. Now, some bats flap their wings slower and some do it very fast. I will remove the stroked rectangle. I can also take enemy image variable from line 9 and actually make it a property on JavaScript class like this. This.image equals new image. This.image src source is enemy1 png. I delete that. And inside draw image on line 34, I refer to this.image instead. By changing value of number of enemies on line 6, we get a different number of bats in our project. Currently, our bats just fly away from canvas and never come back. We don't really want that. Let's create the first, simplest movement pattern, which will simply be just randomized, jumpy, chaotic movement. I comment out this.speed on line 17, and on line 26 I replace it with math.random times 3. I do the same with this.y on line 27. Since we are adding positive numbers to x and y, all bats are going to leave canvas like this. How about we try a random number between -1.5 and +1.5. Now they kind of stay in place and just wiggle around. We can increase their wiggle by giving this random number a larger range, for example between +2.5 and -2.5. I can see that my initial enemy x and y coordinates are not 100% within canvas. Let's adjust line 15 like this. And since I'm using this.width here, I need to move it after this.width has been declared. Now, they initially spawn within canvas horizontally. These brackets are important. Look what happens when I remove them. They just start from minus this.width, which is wrong. These brackets need to be here. Let's do the same thing vertically for this.y. I reduce the number of enemies to 100, or 10. Let's make the range much larger on line 26, between -7.5 and +7.5. I can just play with these values and get the random simple jumpy movement. This is the simplest way you can animate enemy characters or NPCs for your JavaScript games. We will do 3 more, adding a little bit more complexity each time. Let's see what comes out of that. I will be expanding, deleting and adjusting the same codebase, so if you want, maybe it's a good idea to create a copy of this project at this stage, so you have this movement pattern saved in case you want to use it for your games later. I will be using different enemy sprite sheet and different movement pattern for the next one. I hope you're having fun! For the second movement pattern, we will do something a bit different. First, let's switch to a different sprite sheet here on line 14. I will use image I called enemy2 png. It's different size, so I have to change sprite width and sprite height. Sprite width is 266 pixels and sprite height is 188 pixels. I uncomment this.speed on line 15 and I give each game character a random speed between 1 and 5 pixels per frame, for example. On line 26, I set this.x to be equal to minus this.speed. If I comment out y, we can see that bats just fly to the left in a straight horizontal line, and they never come back. Let's first do a reset check. If this.x from line 20 plus this.width from line 18 is less than 0, meaning when the character moved behind the left edge of canvas and is completely hidden, that's why I included this.width here. When that happens, I want its horizontal x position to be reset back to canvas width, moving it behind the right edge of canvas so that it can do another flyover. Now we have endless right to left movement. Awesome. We already have something interesting here, but what if I want them to sway up and down as they flap their wings, making it a bit more dynamic? And if these were enemies in my JavaScript game, maybe it would make it a bit more difficult for a player to avoid them. How do I create wavy movement? Do you know what sine wave is? Let's do a little bit of very simple, beginner-friendly trigonometry. Trigonometry is a branch of mathematics that studies relationships between side lengths and angles of triangles. We use it to create wavy and circular movement in our JavaScript animations thanks to built-in JavaScript math methods. Today we will have a look at Math.sin and Math.cosine built-in JavaScript methods. Sine is a trigonometric function of an angle, defined in a context of a right triangle. All we need to know for now is that Math.sin returns the sine of a number we pass to it. That number represents angle value in radians, and it returns numeric value between -1 and +1. So this input angle value it takes, if I put it inside animation loop and slowly start increasing it over time by very small amounts, when I pass this angle value to Math.sin, it will return a series of values that endlessly cycles between -1 and +1, making it easy for us to convert these values into wavy movement, so-called sine wave. What I just said might be a bit complicated for beginners and it might not make much sense yet. Let me show you. I will need this.angle property on my enemy class constructor, and I initially set it to 0. This is the number that will be increasing, and after being passed to Math.sin, it will give us that series of values between -1 and +1, as I just mentioned. Let's do it so you can see. On line 28, I set position y plus equals Math.sin, and I pass it this.angle. Then I increase this.angle by 0.1 for every animation frame. As the angle slowly increases, do you see the waves? I can change the value here on line 29 to change shape of my sine wave. Angle doesn't have to start from 0, it can be a bit randomized. Let's try with math.random times 2. It will not be very visible. It will become clear what it does a bit later, I will point it out. Quickly set, starting value of this.angle determines what position along the sine wave this particular character appears at first, before it starts moving. It's more obvious if we map movement to a circle, and we will do that in a minute. I can also randomize the speed at which angle value increases on line 30. I do that by creating a new property called, for example, angle speed, and I set it to a random number between 0 and 0.2. Then I take this variable and I replace this hard-coded 0.05 with it. Now, each enemy has its own angle value that is being increased by a slightly different amount for each frame. This will randomize the wave shape for each enemy. Let's set this.angle to 0 for now. I reduce the number of enemies on line 6. As I said, Math.sin returns values that cycle periodically between -1 and +1. What if I want to make the curve more prominent? I can simply just multiply it times 3 here on line 29, and now we are getting values that cycle between -3 and +3. Do you see how the sine wave of enemy movement is more prominent? Look what happens when I put different numbers here. I hope it's becoming more clear what I'm doing. If I put times 10, we get a very prominent curve. If these are enemies in your game, good luck to all players trying to avoid them. Especially for certain sprite sheets, this movement might be very suitable. Maybe you have some strange aliens in your space game and you want to move them in this weird wavy pattern. Instead of hard-coding number 10 here, I can, again, put this value in a variable that will be randomized for each enemy. That way, we get even more variation in movement between enemies. I will call it this.curve, for example. Sorry about my variable names, sometimes it's hard for me to come up with suitable names for all these custom properties. I hope it's becoming at least a little bit clear what each of these properties does so far. I want curve property to be a random number between 0 and 10, and I replace this hard-coded 10 with it, here on line 30. Maybe 10 is too much. Let's do times 7 here on line 26. Do you see what we just did? Some of them move in a very prominent waves, some have barely any vertical movement. This would make our game more unpredictable. I can add as many enemies as I want. Let's put 200 here on line 6. Haha, bat infestation. This will be a hard mode in my game. So we did endless horizontal movement with vertical sine wave element to it. What if we bring it a step further and also add some trigonometry for horizontal x coordinate? We can make the enemies move in all kinds of different shapes and patterns that way. Let me show you. As usual, I will first swap to a different image. On line 14, I set image src to enemy3 png. I check my sprite sheet and I see that width of a single frame is 218 pixels and height is 177 pixels. Let's comment out lines 29 and 30, which will stop our character from moving around. On line 29, I want horizontal movement to be cycling within a certain range. I call Math.sin and I pass it this.angle from line 24. this .angle value is increasing over and over on line 31 as update method is called from inside animation loop. I will also multiply it times Math.pi divided by 180. Let's just experiment here a bit. If I multiply this whole thing by 10, nothing happens. 50? We see some movement. 100? Yes, they are moving now. This angle speed on line 25 affects how fast angle value on line 31 is increasing. If I set it to 0.9, they will move faster. Times 2 might be a good speed for now. They kinda disappear behind canvas edge. I can move them by adding some value to this .x position like this. Plus 10 will move everything slightly to the right. Plus 100? How about plus canvas width divided by 2? I want to center them horizontally. Now they are too much to the right. I need to offset them by the amount of their width. I changed this .curve on line 26 to be a random number between 0 and 200, and I replace hard-coded 100 on line 29 with this .curve property. Now some of them move in a large range, some only in a small area. As we said before, Math.sin, when we feed it an angle, it will return a value between +1 and -1. Since this angle is ever increasing on line 31, we are getting a continuous series of values that endlessly bounce between -1 and +1. By multiplying all of this by this .curve here, for characters that have this .curve 200 for example, they are endlessly cycling between -200 and +200. Put it in brackets. Actually, this has to be this .width divided by 2. Yeah, now they are centered horizontally. On line 29, we are animating horizontal X position. Let's also do this with this .y on line 30 and see what happens. If I copy the same formula and replace width with height, because we are dealing with vertical movement, we get this pattern. This is where cosine comes in. I'm not going to explain trigonometry in detail in this video, but the main idea is you have a circle and radius of that circle can represent hypotenuse, the longest side of a right angle triangle. If we connect lines like this to complete the triangle, sine value represents relationship between opposite side of the triangle and hypotenuse. Cosine is the relationship between the adjacent side of that triangle and hypotenuse. Hypotenuse size never changes, but sine and cosine cycle periodically as the size of opposite and adjacent side of this imaginary triangle changes. As a result, sine and cosine complement each other to map a circular path, and that's what we are taking advantage of here. Math.sin is creating periodical horizontal movement for me on line 29, and on line 30, Math.cosine is doing that for vertical values. Together, they complement each other in a way that results in a circular movement. You can play with these values, swap sine and cosine, make both of them sine or cosine. It should illustrate it better what's going on if you see how these changes affect our animation. If I want to have some space in the middle, we know that this .curve determines radius of the circle my characters are moving in. That value is randomized for each one. I can give it a minimum value. For example, let's do a random number between 50 and 250. I can also change angle speed on line 25. This will affect how fast angle is increasing on line 31. And because that angle is being passed over and over to Math.sin and Math.cosine, it will increase that speed at which our characters move along the circular path. See, here we already have some interesting movement pattern for our enemies. I could use this in some parts of my game. Right now, sine and cosine are even. What I mean is, they cycle between the same set of values over and over, which results in even circular movement. What if I make the horizontal position to cycle at half the speed compared to vertical position by saying Math.pi divided by 360 here? Now, vertical position does 2 cycles while horizontal position does only 1 because of the difference between 360 and 180. These two values here. This will give us a different movement pattern. If I give both of them the same number, it will be a circle. Smaller numbers will result in a faster movement. The resultant movement is always a relationship between these two values. These values don't have to be directly divisible by one another, but it might help to visualize it better. For example, here horizontal position will go over 5 cycles, while vertical position will do 1 cycle. It's because of the relationship between 90 and 500. It gives us interest in movement. I can change their speed also by adjusting this .angle speed on line 25. So this technique can be customized to achieve movement pattern you are looking for. Maybe your game starts easy, but later it becomes more difficult, so you need faster enemies. If I put 360 here, 360 is divisible by 90. If you watch the animation, we will get 4 horizontal cycles before we get 1 vertical cycle, because 360 divided by 90 is 4. Don't feel like you have to fully understand sine and cosine at this stage to take advantage of this technique. I will make a special video where we deep dive into this functionality. For now, this is all we need to know to be able to use this for our games. If I want this shape to be number 8, I can just make vertical value double of horizontal value here. I can play with different numbers and see what happens. I can also have cosine for both like this. It will cause them to backtrack, to go back and forth following the same path, rather than moving in circles. Swapping sine and cosine will make our characters follow circular path in the opposite direction. I don't like how they fill the entire width, but they don't fill the height of my canvas. How do I make them use all available space? We are using this .curve, which is a random number between 50 and 250, and it makes them move within that range. What if I replace it with canvas width on line 29? Okay, that's too much because this value is a radius of their movement, half circle. If I want them to cover width of canvas, I need to give them canvas width divided by 2. Much better. Let's do the same for vertical position on line 30, canvas height divided by 2. Awesome, now our movement path is even more obvious. I will increase number of enemies on line 6, just so that we fill the path with more objects and see it better. Now you can clearly see that our enemies are running along a set path. Shape of this particular path is determined by relationship between 90 and 270 here. 3 horizontal cycles fit into 1 vertical cycle, because 270 divided by 90 is 3. If I make the values the same, we get circular path again. It's an ellipse because I'm stretching the movement here and here. 180 in X and 90 in Y will mean 2 vertical cycles happen before we get 1 horizontal cycle. What happens if I swap 180 and 90? Interesting. To get 8 shape, I would have to swap sine and cosine here. Are you starting to understand how these values affect the shape of path our animated characters take? You can play with this for a while, experiment with different values and see what happens on canvas. Trial and error can sometimes be the best way to come up with unique, interesting results. Trigonometry is a big topic and we will come back to it in some other course. I'm sure some of you get other ideas for this technique. It doesn't have to be used for patrolling enemies in games as we are doing here. You can, for example, use it to create automatically moving particle effects and animations for website and many other things. Creative coding gives us a lot of opportunities to come up with unique, beautiful stuff, and that's why we are building these projects together to improve our vanilla JavaScript skills and at the same time to explore what's possible. Maybe it will spark new ideas in some of you. I know that there are many creative people watching my videos. I'm just here to give you the tools. Where you take it and how you decide to use it is up to you. We can play with these values and create different paths. This .angle property on line 24 determines where along our path our animated characters appear at first. I can spread their starting position along the path by using Math.random. I could have also used something a bit more unusual like oscillators or Perlin noise here, but I want to keep this video beginner friendly. We can do more advanced path following and random movement algorithms later. Another simple technique uses a completely different trick, and it results in what I think is the best movement pattern if you want your enemies to appear like they have mind of their own. At least when we stay in the world of simple beginner algorithms. There are many advanced AI techniques you could use, but this is JavaScript for beginners. You might want to make a copy of this codebase, because to achieve the next effect, I will break this one a little bit. Let's delete lines 24, 25 and 26. I will also set this.x and this.y to 0 inside my update method. And I delete line 28. I comment out lines 26 and 27, and now initial x coordinate is randomized on line 20 and vertical coordinate is randomized here on line 21. I will create a new property. I call, for example, new x, and I set it to random number between 0 and canvas width. I do the same for vertical y coordinate with this.newY property. So I have initial horizontal position on line 20 and I have new horizontal position on line 22. On line 9 I have game frame variable that is endlessly increasing inside my animation loop. I will say every time game frame is divisible by 30 with a remainder of 0, which basically means every 30 frames of my main animation loop, I want to reset this.newX and this.newY to a different random position. Basically, I just need to copy lines 22 and 23 here. Now, I will calculate variable I call, for example, dx, distance on horizontal x-axis. It simply is the difference between this.x from line 20 and this.newx from line 22. dy, distance on vertical y-axis, is this.y from line 21 minus this.newY from line 23. Now that we have distance between current position and the new position, I can make characters move towards that new position by saying this.x minus equals dx from line 32 and this.y minus equals dy from line 33. It's resetting too fast. Let's change 30 to 60 here on line 28. Now we get instant position change every 60 frames. I can make them travel towards that position by saying dx divided by 20. I can also do that for vertical position by saying dy divided by 20 here. Now, current position is always moving towards the new position by 20th of their distance for every animation frame. I can increase these numbers to make them move slower. I can also increase the interval on line 28. I like this, but you can see that positions reset every 100 frames for all enemies at the same time. That looks a bit weird. I want each character to reset at its own randomized interval. I create a property I call, for example, this.interval, and it will be a random number between 50 and 250. Then I replace hard-coded 100 with this.interval on line 29. It won't work yet because this.interval is a random number with decimal points, so game frame will never be divisible by that very specific number with a remainder of 0, so new positions will never be calculated. To fix that, I need to wrap this in Math.floor, which will round it down and make sure we get only integers, whole numbers without decimal points. Awesome! Now you can see that each enemy is moving at their own rhythm. I can add more enemies on line 6. It kind of looks like a swarm of mosquitoes. I also need to swap enemy sprite sheet to keep up with tradition. I will use enemy 4 PNG here. I look at my sprite sheet and width and height is 213 pixels this time. There are many other calculations and algorithms that you can use to make enemies move in a certain way. Let's make that today's challenge. Can you alter some of the code we wrote today and create your own movement pattern? You can also make enemies follow the mouse or maybe try to avoid it. There are many ways to make this interactive. Let me know in the comments if you watched all the way here. If you did, well done. Today we added an important set of techniques to our vanilla JavaScript game development toolkit. I'll see you soon. If you want more game development, check out my playlists. Links in the video description.